and cellular basis of life. So let's discuss about the elemental composition of living matter. There are about 92 naturally occurring elements in the Earth's crust. So you should know, particularly for MCQs, they may ask this point. There are about 92 naturally occurring elements in the Earth's crust. So in our Earth's crust, what do you find? We find 92 elements that occur naturally, of which about 20 to 25% of the elements are essential to continue a healthy life and also very important for reproduction. So out of these 92 naturally occurring elements, right, 20 to 25% of the elements are essential to continue a healthy life and also for reproduction. Now, that 20 to 25% can be understood in terms of animals and plants. So when we consider animals, we can say about 25 elements are essential, right? About 25 elements are essential for humans, and 17 elements and about 17 elements are essential for plants. So next, oxygen, carbon, hydrogen and nitrogen make up 96% of the living matter. It's very important. Again, they can ask for MCQs. Now, I may actually construct questions. I may make MCQs and give you, after discussing a particular topic, very hard MCQs sometimes, so that you can try those MCQs and recall what you learned from this video. So at the end, you can have a better understanding. So let's do this first. Oxygen, carbon, hydrogen and nitrogen make up 96% of living matter. So oxygen, then carbon, hydrogen, nitrogen. You can remember that as CHON. C-H-O-N. You can remember that as CHON. Makes up what? 96% of the living matter. So CHON, you can remember it as CHON, makes up 96% of the living matter. Now the next thing, calcium, phosphorus and potassium and sulfur make up most of the remaining 4% of the mass of the organism. So remember the word most of the remaining 4%. Most of the remaining 4%, which means calcium, phosphorus and potassium and sulfur, they don't make all of the 4% of the mass of the organism, but they make most of the 4% of the mass of the organism. So we have calcium, we have phosphorus, we have potassium, we have sulfur. Now, why do they say most here? Most of the remaining 4%. Why most? Because we have the trace elements also. We are going to discuss later, like, what are the trace elements like boron, cobalt, copper, chromium, fluorine, iodine, iron, those elements. So that's why they say make up the remaining 4% of the mass of the organism. So once again, calcium, phosphorus, potassium, sulfur. We can remember that as cap case. A cap, right? You are wearing a cap. You can say case. In that cap it's imprinted KS, right? Cap case. Remember, you have a cap like this. These are tricks to remember. You have a cap like this, and in that cap you can say KS. A cap case make up the remaining 4%, right? Most of the remaining 4%, not the remaining 4%, but most of the remaining 4% of the mass of the organism. So when you're considering about humans, CHON, C-H-O-N, accounts for 96.3% of the body mass. So we are considering humans now, right? When you're considering humans, earlier we considered generally, now we are considering about humans. When considering humans, we can give a definite number like 96.3% of the body mass. So when you consider humans, CHON, CHON, accounts for 96.3% of the body mass. And now you have calcium, phosphorus, potassium, sulfur, sodium, sodium, then you have chlorine, and then magnesium additionally, and trace elements account for the remaining 3.7%. Right? So we have calcium, we have phosphorus, we have potassium, we have sulfur, same as before. Cap case, we understood that. And then we have additionally salt. You can remember it as salt, sodium chloride. So you can remember not together, but sodium and chlorine. Right? We have that. And then additionally, remember you have magnesium. And also, to make the minute quantity, we have trace elements. Right? That means most of the 3.7% of the elements comprise of calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. Most of the 3.7%. But the trace elements account for a very small amount of the remaining 3%, 3.7%. So what are the trace elements? Boron, cobalt, copper, chromium, fluorine, iodine, iron, molybdenum, manganese, selenium, silicon, tin, vanadium, zinc. Right? So go through this. You can watch this video again and watch this again, because it's better to watch that again so that you can remember it better. Watching it once is not enough actually for a subject like biology. Now there are many things to study, so I don't need to repeat what I taught again. It's better for you to rewatch this video. I can do you one favor. I can make questions and give you, particularly MCQs, which can test your knowledge and your memory about what we learnt. Now, the next topic concentrates on physical and the chemical properties of water important for life. Now, water is a vital inorganic molecule. So we can say water is a vital inorganic molecule. Right? So it's an inorganic molecule because water doesn't have carbon, but it has hydrogen, it doesn't have carbon. So water is a vital inorganic molecule. It doesn't have carbon, that's why it's inorganic. Now water is a vital means important. What is a vital inorganic molecule? Now they say life could not exist on this planet without water. Yeah, life will not exist on this planet without water. If you don't have water, you don't have life. It is important due to the following reasons. So the major reasons for water to be a vital inorganic molecule. What are those reasons? Now life could not exist on this planet without water. Now what are the reasons for it to be a vital inorganic molecule for life? For the existence of life. Number one, vital chemical constituent of living cell. So it's a vital chemical constituent of living cells. So if you consider a living cell, it's a vital chemical constituent. It also provides a biological medium for all organisms, right? So the first factor, it's a vital chemical constituent of living cells. So it's present in your living cells. And for, when reactions to happen, you need water in a cell, right? Now, for enzymatic reactions, many other functions, water. You need water. To maintain the shape of the cell also. There are so many functions. It's a vital chemical constituent of living cells. It provides a biological medium for all organisms. Now, what do you really understand from this statement? Provides a biological medium for all organisms. Actually, when water provides a biological medium, we consider it provides a particular medium for chemical reactions to happen, or more specifically biochemical reactions to happen. Right? Chemical reactions happen in your cells, right? So for reactions to happen, you need a biological medium. So water provides that biological medium for all organisms. Now, most of the above properties are based on the chemical structure of the water molecule, right? So physical and the chemical properties of water molecule provide the ability to render the vitality. So what provides the ability to render this importance, this vitality? The physical and the chemical properties of water, of the water molecule, provide the ability to render the vitality. That means the physical and the chemical properties of the water that we are going to discuss actually are responsible for these vital functions, like vital chemical constituent of living cell, right? What is the vital chemical constituent of living cell? And we said that water provides a biological medium for all organisms. So for those two reasons, right, the physical and the chemical properties of water are responsible. So water molecule is a small, polar and angular molecule. So when you consider a water molecule, we can say it is a small, polar and an angular molecule. Now this is the water molecule. So you can see hydrogen has obtained, right, a delta plus partial positive charge, and oxygen has obtained a partial negative charge. Now due to this, what can you say? Now how did this polarity come into being? This is because oxygen is more electronegative than hydrogen. Therefore it has a partial negative charge, and hydrogen has a partial delta positive charge. Now because of this, polarity comes into being. Polarity of the water molecule is because of this differentiation into charges. So we'll discuss about that. So polarity is an uneven distribution of charges within a molecule. They have described that, right? So polarity is an uneven distribution of charges within a molecule. Polarity is an uneven charge distribution within a molecule. So when there is an uneven charge distribution within a molecule, right? I'm giving you an activity, right? Use your chemistry knowledge and see how the dipole moments act here, right? I'm not going to do that. You know how dipole moments act, right? From that, by examining how dipole moments act, you can see why water is a polar molecule, right? Now, you know, when you consider carbon dioxide, right, there are polar bonds. But though the carbon dioxide molecule has polar bonds, because of its linear structure, it's non-polar, right? Remember that, right? So, but here, actually, this is an angular molecule, and its electron pair geometry is tetrahedral. And because of that, it has a polarity because it has a dipole moment also. Use your chemistry knowledge, right? You all have an activity to do at home. So polarity is an uneven charge distribution within a molecule. Now in a water molecule, oxygen atom is slightly negative. We discussed that, right? Oxygen atom is slightly negative and the hydrogen atom is slightly positive. Now the weak attractions between the slightly polar hydrogen atom of one water molecule and the slightly polar oxygen atom of the adjacent water molecule are known as hydrogen bonds. So they may ask, what are hydrogen bonds? So we have to give the definition. Weak attractions, right? They are weak attractions. They are not very strong. They are weak attractions between slightly polar hydrogen atom, of one water molecule and the slightly polar oxygen atom of the adjacent water molecule. So what's that again? Weak attractions between the slightly polar hydrogen atom of one water molecule. Right? We are considering the hydrogen atom of one water molecule, the slightly polar hydrogen atom of one polar molecule, and the slightly polar oxygen atom of the adjacent water molecule. Now I'll explain that. So what does that really mean? That is this. So you can see this is a hydrogen bond, right? What I've circled is actually a hydrogen bond. This is a hydrogen bond. So why do I say this is a hydrogen bond? Because we can see, as per the definition, right? What has the definition said? A weak attraction between the slightly polar hydrogen atom. So where is our slightly polar hydrogen atom? Here we have the slightly polar hydrogen atom here. I have ticked that there. And then they say, and also between the slightly polar oxygen atom of the adjacent water molecule. So not of the same water molecule, but of the adjacent water molecule. So we have H delta plus of one water molecule and O delta minus of the adjacent water molecule. I hope you got it. So we can look at that again. You see, right? We have the hydrogen having a small delta plus charge. That's one molecule of water. And then we have another water molecule. Let's call this water molecule number 1. We call this water molecule number 2. So number 1 water molecule has a hydrogen having a delta positive charge, and number 2, you can see there, an oxygen atom with a delta minus charge. So between that oxygen molecule having a delta minus charge and the water molecule having a hydrogen atom with H delta plus, now between that H delta plus and O delta minus, there's a bond occurring, and that bond occurring is known as the hydrogen bond. Now the properties of water arise due to the attractions of different water molecules. So the properties of water, right, arise due to the attractions of different water molecules. So water molecules have to actually communicate with each other to show these properties, right? They have to talk with each other. So the properties of water arise due to the attractions of different water molecules. Now because of these attractions only, the properties of water molecules are apparent. When the water is in liquid form, its hydrogen bonds are fragile, right? Are very fragile. What do you mean by fragile? Weak, right? So when water is in liquid form, its hydrogen bonds are very fragile. So what happens to those hydrogen bonds? They, number 1, they form. Number 2, what happens to them? They break. Number 3, they reform with a great frequency. That means at higher rate. So what, very fast, what happens very fast? Hydrogen bonds break, they actually hydrogen bonds form, right? Then what happens? They break, then they reform again, right? Break and reform. Now first they form, hydrogen bonds form. Then what happens? They break, then they reform, right? This happens at a great frequency. That means it happens very fast. Forming, breaking, reforming with a great frequency. Now 4 major properties of water to maintain life on Earth. So what are the 4 major properties of water that are important to maintain life on Earth? So there are 4 major properties of water to maintain life on Earth. So what are the 4 major properties of water important to maintain life on Earth? Right? We have cohesive behavior. We have the ability to moderate temperature. Number 3, we have expansion upon freezing. Number 4, we have versatility as a solvent. So those are the factors, right? These can come for structured essay questions, so please remember them. Cohesive behavior, ability to moderate temperature. Number 3, expansion upon freezing. Number 4, versatility as a solvent. So we are going to discuss about these things, right? Study this, and we are going to discuss about them. Properties of water related to function. So we are going to discuss about the properties of water now. So first we will discuss about cohesive behavior. Now, attraction between water molecules due to hydrogen bonding is known as cohesion. So the attraction between water molecules, right? The attractions between water molecules. Now why do these water molecules attract? Due to the hydrogen bonding, right? You saw that. Let's come to the figure again. Right? Attractions between water molecules. You can see how water molecules are attracted. How are they attracted? By hydrogen bonds, right? Right, then attraction between water molecules due to hydrogen bonding is known as cohesion. The attraction between water molecules and other substances, let's discuss the first one again. The attraction between water molecules due to hydrogen bonding we saw is cohesion, right? Now attraction between water molecules and other substances. See, water molecules and other substances is known as addition, right? Attraction between water molecules and other substances, very important, other substances, right, is known as addition. So we have cohesion and addition. The attraction between water molecules themselves is known as cohesion, and the attractions between the water molecules and other substances are known as adhesion. So both of the above properties of water, right? Both of these properties of water allow water to act as a transport medium. Right? Both of these properties of water allows it to act as a transport medium. We'll discuss why, right? Why do these properties of water allow water to act as a transport medium? We are going to discuss about that. So due to cohesion between water molecules, right? So due to the cohesion between water molecules, water and the dissolved substances such as minerals and nutrients transport through the vascular tissues, xylem and the phloem, against gravity. So due to the cohesion between water molecules, water and the dissolved substances, right? Not only water and the dissolved substances, right? Such as minerals and nutrients transport through the vascular tissues, xylem and the phloem, against gravity. Now what happens now, you see, it's like glue. Now water molecules are together, right? Because of the hydrogen bonds, they are together. They are as a continuous column, right? They're together, they're attracted to each other, they want to stay as one unit, right? As a whole, right? One water molecule is attracted to another, that water molecule is attracted to another one, so they're together, right? So because of that attraction, they can act as a continuous column. So due to the cohesion between water molecules, water and the dissolved substances such as minerals and nutrients transport through vascular tissues. Now there's another point I have to mention, that is, now water actually interacts, right? It interacts with the dissolved substances also. What are those dissolved substances? Minerals and nutrients. Now, you know, for example, glucose, right? You know how water can bind with glucose, right? There are certain interactions with glucose. So it can hold the glucose molecule, right? Can hold the glucose molecule. So the water molecules attract the glucose molecule, and other nutrients also they can attract. So carrying those molecules, carrying those nutrients, right, carrying those minerals along with the water, right, they can transport through xylem. Now addition between water molecules and the cell wall. So water molecules and the cell wall. Addition occurs between what? Between the water molecules and the cell wall. Also helps in the conduction of water and dissolved substances. So addition between the water molecules and the cell walls also helps in the conduction of water. Not only water, also the dissolved substances, right? So the addition between water molecules and the cell wall also helps in the conduction of water and dissolved substances. So what you have to get from this is that actually when water goes through the xylem vessels, right, what happens? I'll show an enlarged image of this. Basically the idea is this: while water molecules attract with each other, what happens? Now water molecules, you can see they attract with each other. While they attract with each other, they also attract with the walls, xylem vessel walls, right? So these attractions that I have shown, right, these attractions also help water to go up along the xylem as a continuous column of water. It just touches the vessel walls, right? The xylem vessel walls. You can see the water just touches the xylem vessel walls. Now, because of that, and also because of the attractions between water molecules, so the water molecules have certain attractions known as cohesive forces, and also water molecules attract with the cell walls, adhesive forces. Now, all of that helps water to act as a continuous column of water, continuous cylindrical column of water that can go up along the xylem against gravity, right? So read that again. Addition between water molecules and cell walls, addition between water molecules and cell walls also helps in conduction of water and dissolved substances. Now water has a high surface tension. Now why do we say water has a high surface tension? They have explained. The ability is given. What ability? The ability to have this high surface tension. This is given to water molecules due to the cohesion between water molecules. So what gives rise to high surface tension of water molecules? The reason for high surface tension of water molecules is the cohesion between water molecules, right? They love to stay with each other. Water molecules love each other, right? They have good attractions known as hydrogen bonds. So they like to stay with each other. So this ability of high surface tension is given to water molecules due to the cohesion between water molecules. Therefore, in an aquatic system, the upper surface water molecules are attracted by the lower surface molecules, and it forms a water column, right? So you learn in physics. Please read your physics now to understand this further. So therefore, in an aquatic system, upper surface water molecules are attracted by the lower surface water molecules. You know how it happens, right? The molecular theory you can learn in the lesson in physics. There's a lesson called surface tension. In that you can see how actually this water film is formed. So therefore, you can say in an aquatic system, upper surface water molecules are attracted by the lower surface water molecules. Now due to this attraction between upper surface water molecules and the lower surface water molecules, it forms what we call a water film. So because of that, small insects such as water skaters can walk on the surface of a pond. There are physics questions also, right? Where they say calculate the force on one leg, right? When an insect walks on a film of water, right? So do those questions and enjoy physics as well as biology. Try to communicate the relationship between these two subjects, right? So small insects, example water skaters, can walk on the surface of a pond. So you can see how a water skater moves in water. This is because of surface tension of water. There's a water film formed. Because of that, these insects can actually walk on water. So next, we have to talk about the ability of water to moderate temperature. So water can absorb or release a relatively high amount of heat energy by a water can absorb. So we are talking about what? Ability to moderate temperature. Water can absorb or release a relatively high amount of heat energy by a slight change in its own temperature. So when water releases heat or when water absorbs heat, the change in temperature is not very large, right? Now why is that? That is actually due to the high specific heat capacity of water. To understand this better, you need some knowledge of heat actually. You discussed that in physics. I just explained that. If you have not learned that, don't worry, just listen to this. You may understand or not understand. Please listen to the rest of the video also. Now, the ones who have learned about this topic, Q is the amount of heat exchanged, heat absorbed or heat released, equals ms delta theta. So what is m? Is the mass of the substance. S is the specific heat capacity of the substance. Delta theta is the change in temperature. Now what can you say? Now water has high specific heat capacity. Now we have to compare two liquids to understand this better. So let's compare two liquids, right? Suppose I'm taking this topic separately because I want to explain this well, right? Separately. It's a very important topic. It's better for it gives you a good understanding for physics also. So let's see. Let's consider two beakers, right? Two containers. One has a liquid. Let's call it L. This has water. Now the specific heat capacity of water is SW. The specific heat capacity of the liquid is SL. If SW is greater than SL, right? And they say heat, let's say a heat of Q is supplied to these containers, right? To the water and to the liquid, right? Let's say Q is supplied by some source, Q amount of heat is supplied by some source to these containers containing water and the liquid respectively. Neglect the heat capacity of the containers, right? Just to understand, we are doing this now. Just neglect the heat capacity of the container. Just think it's plastic or some insulating material. Alright, now we're discussing some physics which is important for biology. Right, now we know SW is greater than SL, which means the heat capacity of water, the specific heat capacity of water is greater than the specific heat capacity of the liquid. Now what? Come back to the equation Q equals m s delta theta. Now I forgot to say we have a mass of m of water, a mass m of the liquid. Now just think, right? M is constant, right? Right? And Q is constant, right? So we have these two to be constant. Q and M constant. So we have to think with S and delta theta, right? Now what can you say? Well, you know, when you consider water, SW is high, which means S is high. Then when you're considering water, delta theta is low. Now, again, I'll use a different color for the other liquid, right? So we can say again, let's write the formula Q equals m s delta theta. S liquid this time. Here it was S water, okay? Now, m is the same, Q is the same. That is, the heat absorbed is the same, the mass is the same, right? Mass of water is equal to mass of liquid in our example. Now, SL is lower. Then to absorb the same amount of heat, right? To absorb the same amount of heat, if SL is lower, delta theta should be higher, right? You want the product of SL times delta theta to be equal to Q. Now again, looking at this one, right? Looking at the water, what can we say? Q equals m SW delta theta. As SW is high, delta theta should be lower, right? To make it equal to Q. So what happens? What can you see from this? Well, you can see very clearly what? That when the specific heat capacity of a substance increases, right? When you're considering equal masses of two substances, when the specific heat capacity of a considered substance increases, to absorb a similar amount of heat, right? When S increases, to absorb a similar amount of heat, the increase in temperature, right, or the change in temperature is lower. Now you understood that, right? Now you come back to this. Now you can understand this very well. Now water can absorb or release a relatively high amount of heat energy by a slight change in its own temperature. Now you understood why, right? Because it has a high specific heat capacity. Therefore delta theta is lower. Delta theta means the change in temperature. Now due to the high specific heat, water will function as a thermal buffer. Due to the high specific heat, water will function as a thermal buffer where in living systems and aquatic bodies during the temperature fluctuations on Earth. That means let's consider a lake, right? You consider a lake. What can you say about the lake, right? When you consider a lake, let's say the water in the lake, and this is the atmosphere, and this is the lake, right? Now suppose suddenly the temperature of the atmosphere drops, right? But the water in the lake, right, when you consider the water in the lake, the decrease in temperature of the water in the lake is not equal to the decrease in temperature of the atmosphere, right? When the atmospheric temperature decreases by about 5 degrees, the temperature in the liquid, right, temperature in the water in the lake decreases by about 1 degrees, like, right? The decrease in temperature is not high. Therefore, what happens? It provides a suitable environment for the creatures, right? For the uh, for the for the fish, for the seals inside the lake, right? It gives this suitable environment because water acts as a thermal buffer. It doesn't decrease the temperature a lot, right? Although the atmospheric temperature decreases a lot, the temperature of water doesn't decrease a lot. Or otherwise, you can say when the temperature of the atmosphere increases, the temperature of the water doesn't increase as much. Now you got it. Right now, okay, so what can we say? Due to high specific heat, water will function as what? As a thermal buffer in living systems and aquatic bodies during temperature fluctuations on Earth. Now, due to the high specific heat of vaporization, what can you say? Due to the high specific heat of vaporization, with the minimum loss of water, an organism can release much heat energy. Now you see, most of the students, right, don't actually see the relationship between biology and physics. That's a big mistake that they make, right? If you want to be a scientist in the future, you should actually deal with all the subjects. See the relationships between the subjects. Now, biology, how it's related to physics, how physics is related to chemistry, how the three are related. How can you see physics, chemistry, and biology in our body, right? In plants. You have to see that relationship, then it's much easier. Now, coming back, due to the high specific heat, water will function as a thermal buffer in living systems and aquatic bodies during temperature fluctuations on Earth. We discussed that. Now, due to the high specific heat of vaporization, with the minimum loss of water, an organism can release much heat energy. So, how can you argue about this, right? So what do they talk about? What are they meaning, right? What's the meaning of that statement? Now, let's discuss that. It's quite simple. I'll use blue color. Now you see there's an equation called Q equals ml. Have you heard of that? Q is the amount of heat absorbed or released, m is the mass of the substance, L is the specific latent heat of vaporization, right? Specific latent heat of vaporization. Now you see, due to the high heat of vaporization with a minimum loss of water, an organism can release much heat energy. You know, water, right, has a very high specific heat of vaporization. So L is very high, right? When L is high, to release some amount of heat, let's say Q, let's say 1000 joules or something, some amount of heat, okay? If L is very high, the mass m should be lower, right? To get this product equal to 1000, because you know the value of L is, I think, if I can remember correctly, 2 times 10 to the power 6, right? Something like that, joule kg per, right? And suppose Q equals 1000 joules, right? Then 1000, you have to divide 1000 by 2 into the power 10 to the power 6. That means we have 500, right, times 10 to the power minus 3 kg. You see the mass, that is 0.5 grams, right? 0.5 kg, sorry, 0.5 kg, right? Is that correct? Okay, so you see the mass 1000 joules. Compared to the heat that is to be released, the mass of water that has to be evaporated is not a great deal, right? So you understood that from that. All right, then what can we say? Sorry, there's a small calculation error. You see, 500 times 10 to the power minus 6, right? That means what? We can get 500 times 10 to the power minus 3 grams, right? 500 times 10 to the power minus 3 grams. 0.5 grams, right? So the answer is 0.5 grams. So the amount of water that has to be evaporated is low compared to the amount of heat that is released or absorbed, right? So you see, just understand the example. Now we can see that very clearly. Due to high heat of vaporization with the minimum loss of water, an organism can release much heat energy. Therefore, the body surface of an organism is maintained as a cool surface. Right? It's maintained as a cool surface. So that's true. Now, suppose you sweat. Now you sweat, right? When you sweat, there's water in the sweat. Now your sweat spreads over your body surface. Then when the water in the sweat evaporates, what happens? The water traps energy from your body and evaporates, right? The water traps energy from your body and evaporates. It's like this, your hand, right? Water traps the energy, right? It takes the heat energy and evaporates. Therefore, what happens? What happens then? The body surface of an organism is maintained as a cool surface. So you see, due to high heat of vaporization with the minimum loss of water, an organism can release much heat energy. Therefore, right, body surface of an organism is maintained as a cool surface, right? That's the reason why we can maintain the body surface as a cool surface. This helps us to prevent from overheating, right? It prevents the body from overheating. So again, by coming back to the equation, you can see Q equals ml, right? When L is really high, the mass of water that has to be evaporated is low, right? Now, evaporation of sweat from the human skin helps to maintain the body temperature at a constant level. Evaporation of sweat from the human skin helps to maintain the body temperature at a constant level. Yeah. Now, there's something called homeostasis in your body, right? We'll talk about that in a separate lesson, but for now, for the bodily functions, right? For enzymatic functions, for example, a precise and optimum temperature which has to be actually at a specific range. It should not change much. For example, the temperature of our body should be at a value between 35 degrees to 37 degrees, right? It should not increase above it or below it, right? You need that specific temperature, that constant level. Now, if the temperature increases beyond that temperature, what happens? Enzymatic functions will decline because enzymes would denature. We'll discuss about that further. That means enzymatic functions would demolish, right? Therefore, you can say, right, when you evaporate sweat from our human skins, right? When you evaporate sweat from our skins, what happens? It traps the heat and takes the heat away from our body, and this helps to maintain the body temperature at a constant level. Now, also not only in us, in plants also, in a process named as transpiration. We'll discuss about those things further in future lessons. Now, transpiration in plants keeps the body surface as a cool surface and prevents from becoming too warm in the sunlight. Right? Don't memorize these things. Biology is a very beautiful subject. Try to understand it logically, please. Now, transpiration in plants keeps the plant body surface as a cool surface. Why? Because transpiration helps to remove the heat from the plant body, right? Because water is evaporating. Transpiration in plants keeps the plant body surface as a cool surface, and therefore what happens? Prevents from becoming too warm in the sunlight. Plants are exposed to sunlight. They don't have houses to surround them, right? So when plants are whole, they are exposed to sunlight, right? What happens to them? They have to maintain their body surface. They are living organisms, right? They have to maintain their body surfaces as cool surfaces, right? And prevent from becoming too warm, right? I hope you understood this. Two more factors to finish our lesson about water. So, right, expansion upon freezing. Now, generally speaking, in an increase in temperature of any substance, right? So when you increase the temperature of any substance, generally, right, normally, what happens? It reduces their density. So what happens to the density? Normally decreases. And on the other hand, in a decreasing temperature, right, when the temperature decreases, the density increases, right? But when you're considering water, it's quite different. Now why? You know this familiar fact. When the temperature of water falls below 4 degrees, what happens? It begins to freeze and forms a crystalline lattice called ice cubes. So what happens? Right? When the temperature of the water falls below 4 degrees, so when the temperature of water falls below 4 degrees, what happens? Now when the temperature of water falls below 4 degrees, water freezes. Right? Water freezes. The water that was there as a liquid freezes now, right? Then what happens? And forms a crystalline lattice called ice cubes. So they form ice cubes. Now ice cubes, when you're considering, let's consider this. We have an m mass of water. Understand this clearly and simply. We have m mass of water which is in liquid form. We have to convert that into an m mass of water in ice cube form. Right, in ice form. Then the volume V2 resulted, our previous volume was V1, right? Volume V2 resulted is greater than V1. So we can say V2 is greater than V1, right? What is this? Now you know when an m mass of water, when a mass m of water, right, in liquid form is converted into a mass m of ice, right, what happens? The volume increases, which means the density of water has to decrease because the mass is constant. Now you know I'm using physics here, right? It's interesting. Density is mass divided by volume, right? You know mass, we can isolate mass and say mass m equals dv, right? What happens? Mass is constant, right? When a m mass of liquid converts into a mass of ice, mass is constant. It doesn't change, no. But the volume increases, then what happens? The density has to decrease. That's what they say, right? So therefore, water has a maximum density at 4 degrees. Now again, when the temperature of water falls below 4 degrees, it begins to freeze. So the temperature of water has to fall below 4 degrees. Then it begins to freeze and forms a crystalline lattice, right, called ice cubes. Therefore, water has a maximum density at 4 degrees. The graph is something like this, right? Theta. You know, when you go to this direction, theta decreases. When the temperature decreases, what happens? Yeah, as usual, the density increases, right, in this direction. But that is up to 4 degrees only, right? That is up to 4 degrees only, right? But below 4 degrees, when you come to this region, below 4 degrees, what happens? Because of the formation of ice in crystallized ice cubes, right? Because of that, density decreases, right? So understand that. We are using a lot of physics here. This lesson is actually physics based. Therefore, water has the maximum density at 4 degrees. You can see that here. Maximum density at 4 degrees. This top peak, right? I'm circling that part. All right. Okay. Hence, what can we say? Hence, ice floats on the surface of water bodies. It is an important property of water in polar regions. Now, hence, ice floats on the surface of water bodies because the density of ice is lower than that of water. Ice has to float on water. Now, it is an important property of water in polar regions. Right? Why is it an important property of water in polar regions? Because there, we can see organisms in aquatic bodies can survive during the winter. Right? During the winter, you know, ice forms, huge ice columns form, right? But they float on water. Though the ice actually is formed on top of water, underneath fish, right? Seals, they can live. It's like this, right? If you take a frozen lake, at the top ice is formed, right? But at the bottom you can see fish. They're freely living, right? Here you have water. Only the top part is frozen and this top part is floating on water, right? So it's an important property of water in polar regions where organisms in aquatic bodies can survive during the winter. Now, versatility as a solvent. So what is the versatility as a solvent? What do you mean by the versatility of water as a solvent? Now, the ability is given to water due to their polarity, right? The ability to act as this, to be versatile as a solvent. The ability of water to be versatile as a solvent is given because of the polarity of water. Why? Right? Why, you may ask? Because polarity is very important when you're dissolving something, right? You may have heard in chemistry, when a molecule is polar, right, you can form these dipole-dipole interactions and stuff, right? You can lead to hydrogen bonds, many other stuff, right? So polar molecules, for example, glucose, and non-polar ionic, and also when a molecule is polar, you can have dipole ionic interactions also, right? Refer your chemistry books further to understand this part, right? You know, water molecules, right? When there's a sodium plus ion, right? You know how water molecules crazily surround around this sodium plus ion, delta minus, or delta minus, hydrogen, right? So you see, ion dipole interactions, right? You learn in chemistry. So the ability is given to water due to their polarity. Now polar molecules like glucose, right? Non-polar ionic like sodium chloride, you see sodium chloride, sodium plus is surrounded by water molecules, and also you can see how Cl minus ions are surrounded by water molecules. Here delta H plus is there, right? I don't have to draw this stuff actually, but better for your understanding. Please refer your chemistry books further, right? It's very important for chemistry. See how chemistry, physics, everything is involved in biology. That's why it's so sweet, right? Is how it's surrounded. Now, the ability is given to water due to its polarity. Polar molecules like glucose, right? The non-polar ionic like sodium chloride, and both polar and ionic. So lysozymes are both polar and ionic, right? Lysozymes are both polar and ionic. Can be an MCQ point. Lysozymes are both polar and ionic, can dissolve in water, right? If it's polar, it can have polar interactions. If it's ionic, it can have these ion dipole interactions with water, right? Now, because water molecules surround each of the solute molecules, as we can see, right? As water molecules surround each of the solute molecules and also form hydrogen bonds with them. Yeah, it can also form hydrogen bonds, right? Suppose a molecule like this, let's say, right? Y'all can do this alone now. Let's say CH3OH alcohol, right? Separate this hydrogen out. It's delta minus, delta plus. So water. H delta plus interacts with this of the water, right? And with the H delta plus here, O delta minus of water can interact, right? That's what they say. So they can form what we call these hydrogen bonds here. This is another hydrogen bond, right? As you can see, right? So once again, because water molecules surround each of the solute molecules, right? They can surround the solute molecules and form hydrogen bonds with them. Therefore, they dissolve, right? So if we consider sodium chloride, initially it's in solid form, right? Then what happens when you dissolve that in water? Water molecules, what do? They separate the sodium ions and the Cl minus ions, right? By surrounding them, as you can see, right? So solubility depends on polarity and not in their ionic nature, right? we are talking about water. So solubility depends on the polarity and not in their ionic nature. So we have discussed about water fully, right? Rewatch this video. Now we are going to do some questions. I'm going to make some questions for y'all. Some MCQs, about 3 or 4. You'll have to try these MCQs, right? And then see where you got it wrong, right? Let's do it. So I made a question now, right? Just now. Erase this part. Sorry, typing mistake. Right, that's okay. First question, no? Right. Correct statement about the elemental composition of living matter. So underline the word correct statement, right? Correct statement regarding the elemental composition of matter, right? First statement. Now try this question before I discuss the answer, right? About 17 elements are essential for animals and 25 for plants. What do you think? No, other way around, right? About 25 elements are essential for humans, like animals, right? And 17 for plants, okay? The next statement. Iron cannot be a trace element in humans as it is found abundantly in red blood cells. Yeah, you may doubt. Now in red blood cells we have iron as a constituent, right? In hemoglobin we can find iron. So there are so many red blood cells. Why is iron a trace element? You have that question. No, but still, though iron is found abundantly in red blood cells, still we consider iron as a trace element in humans, okay? So that statement is a bit tricky, can mislead you, right? It's a cunning statement. The third statement, only calcium, potassium, phosphorus and sulfur make up most of the remaining 3.7% of the body mass. Is that true? You may be thinking, yeah, I think it's true. No, it's not. Right? It's misleading. Only, they say only calcium, phosphorus, potassium and sulfur make up most of the remaining 3.7% of the body mass. No, it's wrong. Why? They have forgotten about right? But they have forgotten about magnesium and sodium and chlorine, remember? Because they have mentioned 3.7% here. Can you see that? They have mentioned 3.7%. So we are considering humans, right? So we are considering humans. So remember that statement in humans, CHON accounts for 96.3% of the body mass. And we said calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium and trace elements account for the remaining 3.7%. So you see, not the statement. So this statement is wrong. All these three are wrong. So we have two more statements. Magnesium is a trace element in humans, but not a trace element in plants. What do you think? Magnesium is a macro element in both plants and animals, right? Remember that. Both in plants and animals, magnesium is a macro element. So it's not a trace element, right? Magnesium is a trace element is not a trace element, right? Magnesium is not a trace element in humans or plants because magnesium is known as a macro element in humans and plants. Now the fifth statement should then be correct, right? We'll see that. Out of 92 naturally occurring elements in the Earth's crust, only about 20 to 25% will be required to continue a healthy life, right? Correct, right? Out of the 92 naturally occurring elements, well, we have 92 naturally occurring elements about, right, in the Earth's crust, but out of that only about 20 to 25% will be required to continue a healthy life. Though we have so many elements like that, though we have 92 naturally occurring elements, only 20 to 25% will be required to continue a healthy life and also reproduction, right? So the answer is the fifth one. First one, the answer is the fifth one. So I made this question just now. So what's that question? Second one. Yeah, we'll just table dash that the second one. We stop from here. Almost an hour. Consider the following statements A, B and C. Alright. Which of the following properties of water are responsible for the activities mentioned in A, B, and C? So we discussed very nicely about this, right? So statement A says an insect walking on the water surface of a pond. That's okay. Then a man sweats and feels cooler. Third statement says a fish swimming under ice in a cold water in a lake. Should be a fish swimming under ice in cold water, right? In a lake situated in a polar region. So in a very cold area, right? In polar caps, you know. A fish swimming under ice in cold water in a lake situated in a polar region. So that's statement C. Now there are 5 statements. Now I choose the correct one. I'll discuss the answer. Please try this before me. Right? So what's the answer? Answer should be what? The fourth one, right? The answer should be the fourth one. Why? An insect walking on the water surface of a pond. You know, a water film forms because of the surface tension of water. Surface tension of water arises due to the cohesive forces between water molecules. Rewatch the video and understand that again. So that's okay. Statement A, an insect walking on the water surface of a pond. The property that is responsible for that is surface tension. Second statement, a man sweats and feels cooler. Yeah. Take my hand for example. I have water. I'm sweating, right? I'm sweating. Sweat has water. Water evaporates from my body surface. Then the body surface remains a cooler body surface now, right? That is because of what? Latent heat of vaporization, right? Because of latent heat of vaporization. That's also okay. So statement B, a man sweats and feels cooler because of the property of water, latent heat of vaporization. The third statement, a fish swimming, right, in cold water in a lake situated in a polar region. Now you know when you have the lake, right, the top surface of the lake is actually filled with ice, right? So the ice layer floats on water, liquid water. So we have liquid water. On top of the liquid water we have the ice layer, but still, because there's liquid, right, underneath the ice layer, fish, seals, like animals, right, they can, aquatic animals, right, they can live, right, freely. So that property is due to expansion upon freezing, because water freezes upon expanding and the density reduces, therefore it floats on water, right? So the answer is the fourth one. Nice question. All right, so we'll finish discussing from here.